Okay, now we talk about the soil condition. So we're learning about what kind of soil is great for the foundation design. So when your earth is stable enough, now you need to excavate your ground before constructing foundation. There's two different foundation type: sloped excavation and sheeted excavation. Okay, sloped excavation here, and then sheeted excavation. So when you have a lots of land for your building, it's enough land, you might consider the sloped excavation because it's cheaper, also lots of benefit. So for example, when you're designing a building like this here, so this is looks like underground, however, this is lots of air and sunlight coming in comparing to the sheeted excavation. However, if your site is so limited, like urban condition, and then your building locating with adjacent structure or other limit on excavation, you should consider about the sheeted excavation. Honestly, in most urban condition, we use the sheeted excavation because the property is limited. But once again, sheeted excavation is more expensive than sloped excavation. And then this is more step to designing this sheeted excavation because this retaining wall have to be considered about the earth pressure. Okay, so let's look at how we process the sheeted excavation construction. Okay, so we need to follow the shoring process when we process sheeted excavation option. So just kind of remember the sheeted excavation construction process. It is called as shoring process. Okay, so what is about the shoring process? The shoring is the process of supporting a wall from the earth's pressure. Okay, you remember about the retaining wall have to be sustaining the earth's pressure. So this is called the shoring. Okay, to construct sheeted excavation, first step is the cross bracing. Cross slab bracing is the number one step of shoring process. It is bracing extension from one side to the opposite side to retain the earth on both sides before supporting by lacquers. So after cross slab bracing, so we're gonna do the lacquers. But cross slab bracing simply just making the retaining wall, and then this cross slab support the earth's pressure. Okay, but this is temporary the structure. After that, we need to add lacquers. Okay, the lacquer will replace the cross slab bracing. Cross slab bracing is disassembled after settling the lacquer on the wall. So after cross bracing, so it means more about diagonally support the retaining wall from the earth's pressure. So need to be adding the lacquer from the cross slab bracing. Okay, this is a lacquer. Okay, but this is also temporary installation. Okay, so what is about the next step? After lacquers, we have to find out more about the permanent connection. Okay, so after lacquers, so tieback is requirement to support the retaining wall from the earth. Okay, tieback is permanent method to hold between wall and the earth. It is horizontal wire, rod, or anchor used to reinforce retaining wall for stability. With the one end of the tieback secure to the wall, the other end is anchoring to the stable structure, such as concrete foundation into the ground or anchoring into the earth having the sufficient resistance. Okay, so you can see the diagram here. This is a retaining wall here, and then you can see the tieback system. This black hatched part is kind of the compete soil. So means simply connect to the compete soil to sustain the least retaining wall. Okay, so this is kind of more about the process for the shoring process. First one, cross slab bracing and lacquer and tieback for the permanent connection between the retaining wall and the earth. Okay. After installing the tieback, so you have to be also consider about the soldier beam and ragging. This is a retaining wall type. So after installing soldier beam and ragging, you have to be connected to tieback after that. But we have to be understanding how we can design this retaining wall. The soldier pile and ragging wall are used primarily for the excavation support. These walls are constructed by installing vertical soldier pile, which is H-beam. It is installed in advance before excavation begins. The timber ragging can be installed between the soldier pile to retain the soil. So you just kind of remember, before excavating the earth, these soldier beam and ragging install first, and then you're just simply making the continuous perimeter using this wall. And then this one actually support the earth pressure. After that, is need excavating the ground. Okay. So what is about the benefit of the soldier pile and ragging wall? Why is most popular the retaining wall type? Because the ragging wall are the cheapest retention system. Because simply you need a wood, ragging, and H-beam pile. So soldier pile can be installed quickly, and ragging wall are fast to construct. This technique is versatile and allow for the adjustment in the field if necessary. The ragging wall, especially made by wood, is easy to cut, easy to adjust the length. So that's why the soldier pile and ragging wall is the most popular method to making the retaining wall. Okay, so this is a construction image after retaining wall, and then excavating the ground, and then setting up the tieback system here. Okay, this is you remember about the shoring process. So I just kind of bring the one animation to understanding better how we can process the soldier pile and horizontal ragging construction process. Okay, let's watch this video together. So first one, before excavating the ground, you have to be install the soldier beam. Okay, then excavating the ground with a ragging wall. Okay, and simply making out this excavating the ground. Then you have to be following the shoring process to permanently connect from the retaining wall and then the solid earth. Okay, so next one is the different option, the steel sheet filing. The steel sheet filing is another option to make excavating the ground. Steel sheet file are long structure section with a vertical interlocking system that create continuous wall. So you remember for the soldier beam ragging, you need the vertical and horizontal member, but steel sheet filing only need some vertical, the steel sheet file. Okay, so just kind of see what is about the advantage and disadvantage. The steel sheet file, it is extremely lightweight and make easier to lift and handle. It's a very lightweight metal. Okay, so means it's easy to handle from the contractors. Also, steel sheet is reusable and recyclable. Then the file length easily adaptable because you see the hole here. This hole. This is easy to connect other steel sheet. It means it's easy to extending the length. Okay. Also, it is easy to weld or bolt it to making it works. However, it has also some disadvantage. It is extremely difficult to install steel sheeting in a soil that is rocky or has large boulders because it is lightweight metal. It is very difficult to make the penetrating the solid earth condition. Okay. Also, it driving the sheet may cause neighbor disturbance. The steel sheet is super tall and big, so that's why you need a big transportation system. So means sometimes if your construction site is too narrow, it's very difficult to install the steel sheet filing system. Okay, so next animation introducing about how it install the steel sheet filing. Okay, let's watch it together. So simply everything's vertical member. Simply connect from the top to bottom. Okay, after getting the or installing the steel sheet filing, then excavating the ground. Okay. Then after installing it, simply getting out of the earth. Okay, and then you can just make it a continuous retaining wall. The next one, soil mixture. The soil mixture, it is the existing earth replaced with a stronger cement material. Simply you can see the diagram here. So this is simply just making the machine, the device, and then it just can making the hole, and then you keep injecting the cement inside, and the earth repressed the cement in making out some continuous concrete cement wall. The advantage, the depth greater than 200 feet can be achieved, but it is little waste material also generated. However, this kind of cost is much more than the other option. So that's why you have to be choosing the proper option depending on your budget, depending on your construction type, depending on the condition of your earth. Okay. So next one, you can see the animation understanding about the soil mixing type. So just better understanding through this animation. Just you can see simply drilling the hole. So drilling the hole and then injecting the cement. You can see the injecting the cement. This cement actually the making of the continuous column. And in this continuous column to make the continuous retaining wall. Okay. So now we talk about the soil type, how you can find out complete soil, and then so we also talk about excavation. When you find out complete soil, you have to be excavating the ground for the foundation. But when you excavating the foundation, when you excavating the earth, when you find the water from your site, how you can do? How can you do if we find the water resource after excavation? As you know, water is our #1 enemy. It makes weaken building structure and cause the building collapse. So means we have to get out of the water as much as possible for your foundation design. How you can getting out of the water is very easy. It is called as the dewatering construction. So dewatering, getting out of the water from your site. The simple pump water from the pit. In the excavation, getting out of the water from this pump. This is a kind of more typical method. But if you find the actual water resource, not just kind of this rain water, if you just find the actual water resource, how you can do? There's two different methods to getting out of the water resource. Okay. The first one, Wearpoint System. The Wearpoint System here, the water is collected in a deeper part of the excavation and pumped away. So you just kind of see from this diagram, this is the actual water level here. And then you install, you're setting up this pump, the vertical pump, just following the building perimeter. Okay, and then this is actually connect to the actual well point, and then they just kind of turning on the pump. They just keep getting out of the water from the site. Okay, and then water level is lower down, and then water level finally lower than your site. Okay, so this is kind of our first dewatering method. Okay, I also bring the video So this is very well to explaining about the Wearpoint system. Let's watch it together and then we talk about next dewatering system.
This animation describes a Wearpoint dewatering system. The first image shows the natural groundwater level at the construction site. A Wearpoint system is installed around the perimeter of the construction site. This image shows the header pipe for a dewatering system on a project in Boston. A Wearpoint is also visible. This view shows the Wearpoint system installed. The system consists of a series of wells connected through a header pipe that is connected to a pump. The individual Wearpoints are typically installed by jetting them into place. The Wearpoint is a small diameter pipe, 1.5 inches, with perforated pointed end covered by a steel mesh filter. The mesh helps to stabilize the groundwater flow and prevent a quick condition. The pump is sized to provide the correct vacuum and head to withdraw the water. The Wearpoints are spaced to provide adequate draw down contours around the site. Water is pumped into a Wearpoint, creating a quick condition with the tip allowing the vertical pipe to lower. This is called jetting. This image shows the parts of a Wearpoint. Casting A is at the tip, and this allows for the jetting action by pumping water down the pipe. The ball valve prevents the water from flowing through the tip into pipe when the dewatering pump is activated. The inflow pipe section is perforated and covered by a screen. This is where the groundwater is drawn in during dewatering. After installing, the Wearpoints are connected to the pump system. When the pump is activated, the groundwater is drawn down as shown here. The final groundwater contour will take time to achieve. After this level is obtained, excavation can occur. After excavation, construction can be performed in a dry condition. The dewatering system stays in place until the below-grade construction is completed. The dewatering system is removed and the groundwater returns to its natural level.
Okay, so next dewatering system is barrier wall system. So barrier wall system simply the designing the dam around the building and site perimeter. So installing a very low permeability barrier around the perimeter of the excavation to prevent the groundwater. So you can see this is water level. But when you just kind of install this dam, the vertical dam around the building site, it simply protect the water getting into your site. So this is a second option for considering the dewatering. Okay. So you just kind of remember how we can dewatering when you find the water from your excavation condition. Okay, so now we know about the earth condition. Now you know about how you can designing and constructing retaining wall, and then now you know about how you can getting out of the water from the site. So now it's perfect condition to design the foundation. So let's talk about the foundation right now. Okay.